All right, we're going to be talking about getting data for your maps, which you guys already have a sneak preview to, and a resource dump of every GIS resource I've found over my lifetime. But there's a process to that, and there's trade-offs that should be considered when you're going about that and designing your project, especially when we're talking about on a organizational scale. So at the base of this process is the need to define your data model. If you've selected GIS, you're one step in that direction, right? GIS is one of a variety of different data model options. If your data and your need to analyze has some relation to position in the modern world, then GIS is a good option to consider, but not the only analysis tool out there. So we've taken one step in that direction. The next step is to define your area of interest, because as we've talked about before, that goes into your spatial coordinate system that you're going to select. That goes into the scope of the imagery and the vector or other raster data that you're going to go out and collect. So it sets the bounds of where you need to stop worrying about information, essentially. So, for example, I had a project just recently that we're doing for Fish and Wildlife Service on the Kenai Peninsula. I need to collect data for this project area, and I have as a resource the Kenai Peninsula Borough's enormous geodatabase, and I now have all of that residing in a project that I share with a colleague. That's a 60 meg project already, and we've just begun, and we're sharing it over cloud OneDrive. So those are all things that you begin thinking about at the beginning of your project, because you're going to start somewhere and build from there, and it's going to have a trickle down effect, or whatever you call it when you climb up a pyramid effect, over the life of your project. So when you begin to collect the data that you've scoped out in your first step of analysis, you need to be complying with that coordinate system that you selected from the beginning. You need to be organizing it in a way that you will be able to find it and use it again. As you've all seen, sometimes the folder structures for these projects become very confusing. You can be drawing resources from offline servers, from other drives on your own system, from remote access servers, and that all adds levels of complexity to keeping your project organized, especially when you're talking about a long-term project where you might come back and forth to this GIS system over the course of a year or several years, and I guarantee you won't remember where you put everything. So all of that goes into your second stage of your project planning as you begin to collect and compile this information, and hopefully use some system of documenting it. That's something that always seems like it should come later in the process, and therefore seldom happens and is seldom available in time to meet your needs when a crisis occurs. And then after you have collected and compiled all of your data and documented it very carefully, you can start pulling it together and doing the analysis. And analysis can include, actual mathematical analysis of your data or statistical analysis of your data, but it also includes you reviewing your data for quality control to make sure that the content that you've received is accurate, which I would say most of the time the public data sets that I get are between 40% to 80% reliable. People collect a lot of information, they stuff it into a geodatabase, and then make it available. And that's better than nothing. So we can say thank you and move on with it, but you want to be aware of the potential for inaccurate data and how you're going to handle that. If you're working from somebody else's web server, there's not a whole lot that you can do. If you have taken that information and imported it into your own context, you want to make sure that you know that you have now diverged from whatever official source you took it from. So that's an important thing to remain aware of, especially if that's a source that gets updated. So as part of your analysis, you begin to review the quality of these data sets that you've collected, and then perform whatever spatial analysis, whether it's evaluating the size of areas, the slope of different areas, the distribution of points. There are whole realms of spatial analysis that we'll just get to touch on in this class. Your Esri license has, I believe, a full suite of spatial analyst tools, which is a really, really expensive Esri license. So hopefully you'll get a little taste of it, but I encourage you to go on and check out future classes, because there are classes at UAA or wherever you end up that are dedicated just to spatial analysis. And it's pretty neat to get to learn that with a free license. And then the final step of creating this package or this project that you're going to dedicate your blood, sweat, and tears to is reporting it to somebody who cares. So that could just be a GIS server that only other GIS analysts pull from. But if you've done your job well and you've curated your content well, they will be eternally grateful. Students like you guys will be eternally grateful. It also might be presented to the public on a web map so that they can interact with these spatial objects, or a somewhat more static website where they can view your information. I think you've all seen a couple examples now of the Esri story maps, which are not necessarily really integrated with mapping, but typically have a map-oriented content, but are really just a website format. Or you have the traditional deliverables of maps and reports and presentations. So that's the overall process of a GIS project. And those projects can have a lot of different scales. It can be just, the process that you guys have gone through over and over now for your assignments, which is to collect the data. It may be handed to you in a package, but you have to unpackage that, figure out how to use it, figure out where to store it. So you're compiling, you have to perform your analysis of which layers that you need, get those into your map, and create a map. So you guys have already done this over and over throughout this class. We just need to learn how to scale it now. It is expensive. Looks like you guys are averaging around 80%. So keep that number in mind. All right. So this class is about getting GIS data. Where can we get it from? You guys have already seen a lot of my sources on that. So what kind of sources did we take advantage of? Sorry, I didn't throw a Pear Deck on here. I should have. You can use your chat, or you can unmute your mic. Don't be afraid of the mic.
Federal resources, I guess. Like, doesn't the U.S. government provide a lot of information for free on data that you can use?
Yes, they have a plethora of interesting data sources. Many of them are republished on repeating basis. There's my chat window. It keeps disappearing. Yeah. So that's one source.
I noticed.
Any other?
I noticed that like the borough and the municipality themselves have their own sources as well.
yeah, when I started putting together the maps, I can't remember now exactly which assignment that was, but it was an alternative to the map image that you were assigned. I went and found a bunch of different map images, and I don't know, for some reason I wanted to look at Battle Creek, Michigan, because that's where my dad's from, or that general region, and I wanted to find the Kellogg factory. And you know what? There's aerial imagery and a whole slew of GIS data available for the Battle Creek, Michigan area. So I think it's getting more and more common for cities and counties and boroughs, or even larger scale. The state of Hawaii has a beautifully organized GIS database with topics from, you know, public infrastructure to land management to population to traditional names. All those resources are organized in one really helpful place. Alaska was on the right track until we defunded all of that. So hopefully we'll get our act together again and keep moving forward. Alaska Mapper is always a useful source as long as you understand that it's not necessarily perfectly surveyed data. I got myself in trouble with that a couple of weeks ago. I thought I had done good enough checks and I was off by about 30 yards. So that was embarrassing. So recognizing that there's digital data out there and recognizing that there's varying quantity in that digital data, varying quality in that digital data. All right, so the other ways, Alex, yes, there are companies that allow some free use of data, but there's always contracting difficulties behind that. So some of it is understanding, for them to understand whether or not they have the right to share it, and then how they go about sharing it. So it's fairly common in the construction industry. You know, if I know this company tends to work on projects for this client in this area, I'll call them up and I'll say, hey, do you have any spatial information on this spot? Or fairly often I'll call Quantum Spatial and say, hey, have you surveyed in this area, and what's the latest aerial imagery that you have, and is it available for sale? So all of that's out there, and every company has a varying scale on how much data they're willing to give away to a good cause. So never be afraid to ask if you are representing as a student or as just a good cause. If you have a project, it never hurts to ask.
Hey, quick question. Have you ever asked, like, say, GPS Alaska or something like that for that kind of data?
I haven't asked them specifically. I've gotten a heck of a lot of GPS support from them, so it's probably conceivable. They tend to lease out their equipment more to other users. I'm not sure how much data they collect and retain in-house. I'm sure they have some.
Yeah, no, I happen to know, just because of the company I work for, that they do collect data, but I don't know exactly where they use it. So I was just kind of wondering if you had, collected it via that way or not.
I haven't, but I'll make a note of that. And it's always good to have new resources. My technical difficulties have gone to my pens are now turning into crayons. Okay. I can still write GPS Alaska with a crayon though. I don't even have kids, so I don't know where that came from. Okay.
You can also collect data by yourself, right?
Yeah, so that's the next step, right? If you've gone out on the web and you have not found all this like freely available manna from the sky data out there for you to use, then the next step is to go out and collect it yourself. And again, if you stay with the UAA program, there are classes on doing just that, or working for a survey company around town, or even going out with your fancy dancy little iPhone I have played a little bit with collecting, well, I've made KMZ files in Google Earth and loaded them on my phone. I haven't played with going the other direction, but theoretically, that's something that you should be able to do. So you can quite easily build KML and KMZ files in Google Earth and then bring that into your ArcGIS, clean it up. I've done some Google SketchUp modeling for the shed that I designed for my front yard, and I've displayed that in Google Earth. So now I can see it with the 3D SketchUp that Google Earth auto generates for my house. It's pretty cool. I think I'm fancy. Haven't yet built the shed, but we're becoming a 3D modeling world, and there are tons of free tools out there for it. I think Google SketchUp is fun to play around with if you're interested in that kind of 3D modeling of buildings or gardens or anything you can imagine. And that all can exist in a GIS context as well. And then, anything from like the Strava running apps or things like that. I have friends that obsessively track every outdoor activity they've ever done and bring that data back somewhere and analyze it probably more than they'd like to admit. But for collecting data with a drone, I haven't gotten to play with those near as much as I'd like. So I haven't been that tied in with the industry for the last couple of years, but there are so many incredibly cool new things being done with drones, and data collection is becoming cheap. So if anything, we're about to be flooded with an influx of too much data. So if you can't find it, you go out and you make it. The third option is taking old analog data and digitizing it. So I gave you a little taste of this with Lab 3, where I gave you an aerial image and showed you, I can't remember if I did a video or a how-to on how to put that in place. Normally that would kind of be a somewhat advanced topic in GIS, but ArcGIS and actually QGIS's systems have made that so easy that you literally just pick spots on a map and spots on a picture, and it does all the math and puts it into place for you. And it's no longer a complex process. So you guys have the ability to take aerial imagery of all kinds of different formats and put that into your GIS. Now you want to be aware of what makes a good usable image. We're not going to get into the 3D modeling that can be done with aerial oblique imagery, so that imagery that's collected at an angle in multiple places, so you can do like a 3D SketchUp of buildings. But if you have overhead imagery of any kind of area, you can bring that in. I did a project in Unalaska a few years ago, and they were interested in understanding whether or not an area was wetland. And there are some legal ramifications around whether it was an existing wetland, whether it was a created wetland, and whether or not this new developer had damaged any existing wetland. So I got to comb back through back to the 1940s, post-World War II era maps and images, and saw that essentially that entire valley had been strip mined, used for materials for building around Dutch Harbor. And that stream the stream that was forming this wetland area had been moved back and forth across this valley multiple times. So the area that looks like new construction still, because Dutch Harbor changes very slowly, they don't form soils quickly, it's not going to go back to a native vegetated state very quickly, had been under construction since the 1940s. So that kind of changed the information about what had happened to this wetland that now exists there, but wasn't necessarily under the same kind of jurisdiction that it would be if it had always been there.
So then legally it didn't fall under a wetland, did it? Or no?
It does become a wetland at some point, but there's a little bit grayer of an area of how much needs to be mitigated. So I don't dive too much into the legal issues of that, but
I see.
presented things.
Say that again.
Just presented the findings that I had accumulated of, all of these images that I had orthorectified. So I had brought into my GIS program and let somebody else who had to make that decision see the variations over time. So I'm not sure what the city ended up doing with that information, but
yeah, no, that's interesting. Some of the stuff we've done is with wetland delineation and all that kind of stuff, and so in that case, as far as I've heard in the valley, it wouldn't be considered wetland. But then again, I don't know exactly. That's kind of what I was wondering if you knew. But yeah, thank you.
Yeah. It is a bit of a gray area because sometimes the point of creating wetlands is for restoration. So if you damage restoration wetlands, then you're undoing that mitigation. So anyway, getting into the details of why GIS can be really important. So the point of presenting that project was that none of that aerial imagery, few of those images came to me already orthorectified. So I used the tools within QGIS, which are very similar to the tools within ArcGIS, to position those images, make sure that they were all aligned consistently because, positioning systems have improved over the years to get all of those into a point where I could compare. And of course, all of them were of varying quality. So the data that the city went out and collected themselves, which is very recent aerial imagery, was far superior to older satellite imagery that was available. So sometimes going out and getting it yourself is the best way to do it, but then some of the older airborne imagery from war era aerial images was quite good because imaging technology hasn't changed quite as drastically as satellite technology over that time period. It's just the way we get it into the air that has changed so much. So you go out and you find these sources, and they're not necessarily ready for you to use. So most of the cost of a GIS project is taking all of this information in and getting it into a format where you can use it. So the time that I spent orthorectifying those images, while important in enabling me to do that comparison over time, was a substantial amount of the time of implementing it. And then also taking in the city's geodatabase, which they provided to me in order to get a handle on the infrastructure. Even though I wasn't actually performing QC on their data, I had to take it and integrate it with the work that I did. And then take my GPS data from my field data collection, bring that in, and since we don't, for these projects, take out highly accurate GPS, I had to take my probably plus or minus 30 feet or worse GPS data that I had collected and compare that to actual known survey monuments and my orientation of the site within existing highly accurate digital data. So when they talk about it being a one-time cost, that's really applicable to situations where you're taking a completed geodatabase, like the one I mentioned, and putting it to a new use. I got to skip all of the potential costs of trying to understand where exactly that stream was located today, because they have a good stream mapping system. And I knew where all of the input and output drainages were in that area because they have their sewage system already mapped. So it can look like a big undertaking, just like collecting all of those data resources that I've collected over the years. It looks like a lot of data, but I've collected it a piece at a time, and the pieces that I have downloaded and stored myself all live in one place that I try not to ever move because that would be disastrous. And I can apply that to ongoing projects.
How much do you worry about that data changing though over time?
Depends on the nature of the data.
Mm-hmm.
And yeah, if it's a system that updates on a regular basis, especially if it's a system that is relatively error prone, then you can have conflict between the ones that I've already reviewed and corrected versus newer updated data from the data source, which might have new information attached to it, but still have the same underlying spatial errors or whatever it was that I did QC on previously. So it's not something that I maintain on an ongoing basis, but address on a project by project basis.
Makes sense. Huh?
So there's not enough time in the world. So the nice thing about GIS data, though, is, compared to having a library of maps, I don't know if any of you are familiar with the map store on campus. There used to be one at Fairbanks and one in Anchorage, and I can't remember which one they kept. I haven't been there in a while. But it was a repository of USGS maps, geophysical maps, state archives, federal archives, all available in one spot because nobody really has the resources to own and store and maintain that large of a physical inventory. I don't know if you guys are aware, there used to be a National Archives office in Anchorage, and last I heard that was moving out of state. So we're quickly getting rid of our repositories of paper data in all its forms. But for digital users, that also means we're quickly moving into digitizing the world, which means you barely have to leave your home, which is very convenient right now. I don't know if anybody has found the Internet Archive yet, but I've done a substantial amount of research for this class from Internet Archive sources, and I use it on a regular basis in my work and personal life. And all you need is an account to go check things out for an hour, or sometimes you can get them for a day. So you can learn a lot of cool things that way. So this is just a general overview of finding existing map data. Map libraries are dwindling. They're not going to be available forever. Books are not the wave of the future. They're not updatable, or they're not readily updatable. So you're going to see the majority of all information resources go digital. Obviously, federal, state, and local agencies are going to be a primary resource for data of this scale because it's expensive to collect and QC and maintain. But because it's publicly funded, it's available to all of us. So this is, I think, just a link back to that spreadsheet that listed all of the sources that I shared with you guys before. Some of those are public entities. They're not usually the source of data, They're usually somebody with an agenda to collect data and make it available. And you can take advantage of that agenda. And then when you get up to the bigger budget projects, there are the commercial data suppliers. So I didn't update this section of it, but Digital Globe, which is now known as Maxar, provides aerial imagery to ArcGIS and Global Mapper, and I saw it somewhere else recently. I can't remember. But they pull in a fair amount of the satellite data from a specific system. I can't remember the name of it now. And they sell that imagery. And a lot of it is available to you guys for free. So it's a great resource. You can also go places like Quantum Spatial, and that's the local air mapping source, and purchase aerial imagery from them. We have a project right now for Fish and Wildlife in Hawaii where we're purchasing aerial imagery from, it used to be a government project that's now run by the Arizona State University with a fairly sophisticated airborne LiDAR system. And they do some large area mapping. And I can go and ask them for a piece of it for, you know, only $20,000. So that kind of stuff is available. I can go to Quantum Spatial and I can get one aerial image for probably less than $500. So there's a big sliding scale there in buying commercial data. If you want somebody like Terrason to go out and map a new area for you, you're looking, you know, somewhere starting at 30,000 and working your way up into the millions for their NOAA charting surveys.
So when you say that we are doing what you said you were using data in Hawaii, does that mean, is that like UAA is doing that as a project?
No, most of the work that I'm going to speak of is going to be for my primary employer, which is P&D Engineers. So we assist with some federal planning programs, and one of them is for Fish and Wildlife refuges in Hawaii. So we're getting ready to do some planning and GIS data collection for a refuge to manage their road systems because they're vulnerable to storms. So I've gotten to learn more than I ever thought I needed to know about formatting geodatabases according to federal highway specifications. So all of this stuff is useful and you can apply it in the real world. The next few slides are going to be just kind of an overview. And I see this more as a resource that you can come back to in reference. But if you think about what the different agencies do and what kind of information they might provide to you, you're almost guaranteed that there is GIS data of some form with each of those agencies. So USGS has primary responsibility for maintaining the nation's topo maps. So they're going to be your best source for things like the national map, which we've looked at a couple of times, and topo information, as well as what you might imagine the geological information that they collect and maintain, also geological and geophysical information. NOAA has a responsibility for charting the nation's waters. So you would go to NOAA if you wanted information about oceans. And actually, sorry, for rivers and streams, you would go to USGS. The Census Bureau is going to have annual data sets on population statistics, and most of those are available in GIS format. So you can go, I think you guys have it in one of your maps. This lab is a Census Bureau data set, but you can download those for every census that's ever been digitized anyway, and manipulate that data or look at that data as well. The NGA is, I think they are now, I think I have on a later slide, they have a new name. I think they've gotten rolled in with the National Center for Environmental Information, but they are responsible for geospatial intelligence. So spatial positioning systems and programs on a national scale. The EPA is going to have data sets about potential hazards. So you can find a lot of information about air quality and water quality and hazardous waste sites and a lot of things you may not want to know are mapped in your area. We have a similar program from DEC. All of that information is on the web. So if you want to know where the polluters are, or if you are a polluter, be aware that all of that information is publicly available on the web. And then FEMA provides a lot of mapping and resources for responders to federal disasters. So flood and fire information and infrastructure so that they can help support response. So that's just a list of some of the agencies. I left out the Army Corps maintains map information. I don't know that I have found a whole lot of geospatial information on their charting, but they do have other databases available about ports and harbors. Some of that's going to be probably classified for national security, but I can't think of an agency that doesn't have some sort of application for GIS. So we mentioned the national map. I feel like this list is actually a little bit outdated because we don't typically interact with the national map in quite the same way anymore. It used to be you download the DEM or the contour data and you interpret that and put it to use yourself. But now it's a little bit more interactive. Most of you have visited this site within this class as part of Lab 3, or at least been aware of it through use. So you can go here and you can visualize the data right in the national map, or you can download the sections of it that you need yourself. But there are other resources built in to this national map program. One of them is the Geographic Names Information System, which is an attempt to standardize our usage of names. So just like naming plants and animals, there are as many different common names for some area features as there are people who talk about them sometimes. So we make an effort to standardize those names, at least by having one main centralized source for that data so that people can consistently speak about the same thing. I don't know what name you guys use, but there are at least 4 different names for a crowberry in Alaska, depending on where you are. Probably some of you are thinking, no, she means mossberry or blackberry in some areas. Similarly, Crow Creek could be Moose Creek to somebody else, especially in Alaska. We're not the most creative sometimes when it comes to naming all of these many geographic features that we have around us. So that's something that USGS maintains, and they do still have all of these data sets available, but some of them you would need to dig for a little bit more now that everything's been standardized into this single national map program. So by attempting to standardize this across our nation, it's had the benefit of upgrading the quality of data around the nation. So in areas where we used to spot collect information, now we are going out and programmatically collecting information. Alaska's had some big benefit for that in recent years. They've had efforts to finally collect airborne LiDAR data for all of Alaska. Now it's very high elevation, low resolution aerial LiDAR data, but it's been collected in a systematic way so that we can standardize things across the state. And they have been updating topo maps based on that information. You know, topo maps that were created in the 50s and 60s that could have whole ridge lines in the wrong place. I get to do a geology mapping experiment with that in my geology field camp because the ridge line that we were on was in the wrong place. And by using that in order to interpret our geologic data, it was very confusing trying to figure out how all of these things fit together on a map that was drawn incorrectly. So that's just one example of the benefit that we get from these nationwide improvement programs. It takes a lot of tax dollars, but in the long run, it saves a lot of money because we're efficiently using one centralized source to collect and maintain data rather than trying to spot maintain things as people have local interest. So the second piece of that for federal data is the Earth Explorer program, and it's essentially mirrors some aspects of the national map, but with the focus and I think a little bit more computing power on focusing on imagery and satellite and remote sensing data. So if you haven't already looked at this in your Lab 3 process, it's a good thing to get familiar with. It's mildly annoying in that if you want to download data, you need to have an account. It's a free account, but they do expire periodically, so I've had to make 3 or 4 of them over the years. But just be aware that there could be a free aerial image just waiting for you to come and download it from their site. See, I'm going to do one more and then we'll take a little break. So I looked at GeoPDS. Sorry, we talked about the map store. Now that you no longer have these brick and mortar map stores around, they're becoming centralized in digital repositories. One of them is the USGS map store. So in addition to the national map and the Earth Explorer, they maintain the more public facing version of this, which is this online map locator. And I don't recall now, I downloaded one of these recently. Let's see if it's in my downloads folder still. Oh, yeah, there you go. Let's see, so I was actually looking at Mendenhall Lake in Juneau and trying to figure out how easily I could get somebody a georeferenced PDF, because what they wanted to be able to do was draw dots on this map and use it to tell somebody the coordinates. So this is a GeoPDS, and in order to see the cool tools that come with this, sorry, they've hidden this. I think it's all in the measure tool now. You open it, you can use Adobe or you can use other free programs. I can't remember now the names of some of the other free ones that I've used over the years that can do the geospatial location, but PDFs are an open source that a lot of different softwares use, and not all of them cost a lot of money. So the GeoPDF, if you notice when you are, oops, looks like it's got a bit of a delay. It should not be showing me coordinates outside of the map area, but when you are inside the map area, it's reporting to me coordinates. So let's go over here to, you guys didn't tell me that you can't see what I'm sharing with you.
I was about to say something, but I wasn't sure if maybe you were just trying to figure something out.
I forgot that I only can share one program at a time on here. Okay, let me fix that. Like letting your crazy teacher walk around with like a bird feather stuck in her hair or something. Okay. Here we go. So you can see the corner coordinates of this topo map are 58.5 and negative 134.5. And as I move away from that corner, if you can see in the lower right corner of the screen, it's updating latitude and longitude to report to me. You can also, using this, measure, this is a perimeter tool. So it's going to tell me the length of the perimeter of what I just drew. It does have some minor snapping controls. There's an area tool. So you can go out and use these, I'm being sloppy, I'm not allowed to intersect. There we go. So now I get a little PDF pop-up that tells me that that's 0.64 square miles. And you do have some controls over the information that applies. You also, which I think is even more useful, have control over the layers often that are visible. So if you don't want to see the terrain, you can turn it off and interact with your map without contours. So GeoPDFs are pretty neat. And I haven't done one from Esri for a while, so I'm not sure what kind of improvements that they've made. But it used to be a fairly straightforward process. So we'll see if we can work that in somewhere. And you can download these free for most areas. Any area that's had an updated USGS topo in the last 10 years or so will have a GeoPDF available from the USGS map store. And you can download the digital versions for free. You still have to pay for paper copies of things. But as a digital federal resource, it's free. And that's all through the USGS map store. All right, let's take a little break. I'm getting dehydrated and you guys are probably tired of listening to me dehydrate. I'll see you guys back here in 5 minutes.
Sounds good.